Welcome to a new test and teardown video. This time it's a Power Ease 500. It's a 500 volt power supply, but not just a normal power supply for laboratory use, but this one is for med labs, and they're using this for electro DNA analyzing stuff in gels and voltages and stuff that moves the DNA and all that stuff. I don't know anything about that, to be honest, but I think it's quite fascinating. And for that you need a high voltage. This is a 50 watt supply. It will do a half an amp at low voltage and down to 50 milliamp at the highest voltage. And all that is automatically adjusted on the screen. And there is also an open circuit detection and power off system. So that means if you don't have connections to your circuit, you will have 0 volts output. And that feature, I think you can't disable that. So that means this one can't really be used as a normal DC power supply. That is what we later figured out. So I don't know if I even want to waste a lot of time trying to repair this, because I can't really use it for any normal, regular electronic lab use. And there was a big sticker on the screen where it says defect. And yeah, it is definitely defect. It just goes beepity beep when you power it up. There's a loud beep, and that is all it does. It don't even light up the display or write anything on the display, so it's completely dead. And there are a few reasons for that. The first one I figured out is this switch mode controller IC right there. I think this one is driving the low voltage supply, and then when the low voltage supply is up and running, then the high voltage supply is probably the parts right here and the bigger transformer. So that will be the high voltage supply, and this is the low voltage auxiliary supply, and that one is defect. So that IC here just goes burning hot, and that is what I will try and attack in my first attempts to see if I can rescue this power supply. We got this is a 2-board solution, and down here we got all the microcontrollers and fantastic things. I will of course open this a little bit more, but look at that. What is that? A funny IC upside down doing something for the beeper, and then there's also another little wire doing something, right? You see the little green wire there. But yeah, it looks quite alright. The build quality is alright. And of course this is all switch mode. So that is why you would expect to have a big power entry filter like that. And then another extra common mode choke like that. And this is something they didn't add just for fun. This is because they're just still a few dB over the limits when they tested and wanted to have this product approved. And they failed. So they just figured out, if we add this inductor here, we are just a dB under level, and now you can sell your product legally. That is how it is when you see stuff like that. There's another little nasty thing, and that is products with batteries. Oh no. And yes, this one is also no excuse. This one leaked as well, probably caused some minor damage in this area, but of course this is not the power supply area. But what if this one was stored upside down? Then you'll have the leak go to the power supply. So yeah, I will try and open this and see if I can get a little bit closer to that. Yes, I can also show you the display and the buttons. So there's a button board down here, and that one is just connected to all that. I expect there will be no ICs or anything like that. Here it's just manually scanned here. This is of course the data interface to the entire screen, and see again, filters for the output. Nasty. Well. see. I removed the 4 screws here for the circuit board. And we got these interconnects, but I can't pull out the board. See? And it's because it's stuck behind the fan. And the fan, you can't even unscrew these screws here because see, they are stuck in that piece of metal. So that is, then I need to unscrew here. And I also need to unscrew the printer. There's a parallel printer interface and a really nasty connector for the RS-232. Oh no. And here we can see Power Ease 500 and the NOVEX. This product is also rebranded under another name. I'll show you a little picture so you can see that. I also found a used one for about $500 that should work and pass all sorts of tests. But I think it's a little bit more fun to see if I can figure out what is wrong with this one. So here is the microcontroller board. And the brain is a Motorola 68HC16. And that one is probably some interface and a little local RAM for that. We also got fast RAM here, bus driving, programmable gate arrays, flash for the program. All that is quite alright. It's yeah, this is a 4-layer board, and it's from '95. The layout, I mean, is done in a hurry by somebody who didn't really care a lot about what he was doing. You can see the different routing ideas. See here we got angled, but look at that one. Oop, that's not angled. And all these, the different angles and the way that tracks are routed, you know, it's quite clear that they didn't care about how it looked. I mean, why would you go down here and then up again instead of just going straight and then, you know, distribute your spacing and making it all nice and fine? I mean, this is a sloppy jobby. And this whole idea just continues all over the board. Look at that. The way that stuff is, you know, going up, going down, you know. Oh, let's move this one a little bit away, but not, you know, don't do it proper. It's just really, man, look at all these funny. Yeah, I do PCB designs for a living, so this is why I really love to look at stuff like that. And this is just a very bad example of somebody who was a little bit too fast. A little nasty one there, and look at all these. It's here again. It's just all over the place. The more I look at this, I mean, what the heck? And I don't know if you can see in this area, there's something shiny nastiness in this area here. So this I need to clean up, and then we'll see. Maybe I can boot up the CPU with some external power supply, and then my first idea is to see if I can figure this out, because here is a little low voltage switch mode. This one, see? And those are called simple switchers. They're real easy to figure out. But then there's also a high voltage switcher here. And it's probably some of these components that has something to do with that. But this one is red glowing warm and then nothing happens. So maybe this and this and this has something to do with a high voltage switcher that goes step you down to, I don't know, 12 maybe. And then this one goes to 5 volts or something like that, right? So that is the two levels. So I could probably input some voltage to this system and then figure out if this is working and is this shorted, causing this one not to work. And when all this is up and running, then probably all this is the output power, the 500 volt variable, and this is just a flyback. See, there's a single field effect transistor here. We've got some diodes here, inductor and flyback diode and resistor and all that kind of stuff here. So this is a basic flyback converter. I don't know exactly who is generating the pulses, but it's probably this optical device here and some drivers and stuff like that. And then it's probably done in software or software controlled using those chips here. And they're probably measuring the output voltage using, see, all those resistors and stuff. And then there's probably a feedback loop of some sort, right? Gotta be something like that. Oh yeah, look at that. Burning hot resistor right there, right next to a capacitor. This is how you make sure you don't have a long lifetime of your products. Yeah, I actually got a little bit of progress here. So here's what I did. I soldered a few wires to the input capacitor of this switch mode converter. So it's an LM2575, right? So that is the output, and then I can measure. I got 5 volts out here. When I give it this one some input, I just had the idea it's probably 12 volts on the input. And what do you know? When I give it 12 volts like that, I also got a nice little green lamp here, but there is no response whatsoever. And every time I power this up, now you're gonna see this. And then I turn it on. See, there's a nice little beepity beep. And the fun thing is, if I beep it a little bit like that, sometimes this LED goes on. And if I hold down the power button while I turn it on, then it beeps for much longer time. So that means it is reading this one and it is doing something. Just too bad the display is not up and running at all. And I got all the voltages, I got data, I got CPU running, and I mean no life in the display whatsoever. So that is just a total showstopper. There's no way I can replace the display. So I mean, with a defect display, there's no need to waste any more time on this unit. Just too bad. And sometimes you just need to know when enough is enough. This one is just beyond repair. Too bad. So I'll turn it off. So yeah. And yeah, I think I did already show what this one consists of and what it can do and all that kind of stuff. So, and of course, when we figured out it has this disconnect protection, I mean, I can't really use it for any kind of funny lab stuff anyway. So let's just put this back on the shelf of unrepairable stuff. So thank you very much for watching so far, and yeah, wish me better luck next time.